Okay, now let's try to solve some of these exercises. How many genotypes of gametes can be formed by individuals of the following genotypes? So let's start trying to do solving some of these exercises. So here, just very quick, this will be the answer for this one. This will be the answer for this one. And this will be the answer for this one. And this one, this is the answer. Now let's try to solve the question. Remember to study this law of segregation that depend on the gamete formation. If you remember this, the movement of the chromosome is very important. So when you have the law of segregation, this is why this one will go here. Why you make the Punnett square like this, and this one will go here, because during gamete formation, these chromosomes separate, yeah, and one of these chromosomes will have a different alleles. And also, if you remember, the law of independent assortment is also important and depend on the movement of the chromosomes too. So remember to study that. And so now, how we form these gametes. So there is a rule that is very easy. When you have a homozygous, you only have one option, and when you have a heterozygous, you will have two options. In this case, that you have two alleles. If you have three alleles, you can have three options. But let me show you. So when you have a homozygous, you have one option to make a gamete, because the only option it will be, for example, if it's capital A, you only have your gametes will have the only option. It will be to make or this gamete or this gamete. Now let's think about the heterozygous. So we have this one. In this case, you will have two options. Super easy. You have the option of the capital or lowercase, dominant or recessive. Now, when you have two genes, so you apply the same rule. So you have here in blue you have one homozygous, and in red here you have a heterozygous. So what you do is super easy. So you have one and you will have two. So you have two options, and here you find the two options that you have. I know when you have one gene or two gene, you can just apply this foil technique that we learned before. We just separate them and do the to make the Punnett square, and there is no need. It's very easy. However, when the gamete formation, when you start having more and more genes involved, start getting more complicated. So let's try another one when you have two. So here you have two heterozygous. Let me put it in red. You have one heterozygous here, and you have the other heterozygous here. So now, one heterozygous, the other one heterozygous. So you just have to multiply 2 by 2, and you have 4. So you will have 1, 2, 3, and 4. And just to remind you, this foil technique that I just talked a second ago, you can apply it here. So when you have only two genes, it's very easy. You can apply this foil technique of the first one. First, you multiply the two first one, then the one outside, so A and B, then the one inside, and then so A lowercase and B, and then the third inside, and you get this one. So that one is pretty easy. The problem is, as I said, when you start having more genes. So for example, here, to make the foil here, it will be more complicated and it will take more time. However, if you just use the formula that I taught you, it's pretty quick. So now you have three heterozygous. Super easy. So you multiply 2, 2, 2, because you have 1, 2, and 3 heterozygous. So you just multiply this, and the option is 8. Now, and these are all the options. Yeah. Now so you have 8 gametes. You can, as I said, using the foil is excellent and it's easy with 2 genes. With 3 is more complicated. Now I'm going to give you a different way to solve this. And I post a video of this if you go to the answers of your practice test. Sometimes there is a video, and I post somebody that also solved this exercise in a different way. So for example, he just make these trees that allow you also to make to easily make this type of examples of the gamete formation to solve them. So what it does, so let's start analyzing this. The first gene, the capital I, you have 2 options. The capital A will have B and C, yeah, and the B and C will have could be, all of them could be capital. The other option is all of them are A and B and capital, and C will be lowercase. And you can explore in this, and it's a very easy way to do it. And as a result, so all of them here, as I say, all of them are capital. The other option is you get this one, 2 capital and 1 lowercase. And here, for example, it will be 1 capital, 1 lowercase, and 1 lowercase. So very easy. Now the next step is to go and try to do the other A. So this will be the other option. So you have A here, B here, and C here, all of them capital. So you will get A here, B here, and C here. And you can get, for example, this one, and this one, and this one. So you will get all of them lowercase. And here you just have to count. So you get 1, 2, 3, 4, 5, 6, 7, and 8. And this is how you can, in a different way, calculate how many gametes you have. And remember, you have 2 options because they are heterozygous, 2 options because they are heterozygous, and 2 options because they are heterozygous. And now let's do this one. This is really easy. So you have now so many genes. You have 3 genes, but most of them are homozygous. So if you see here, the A, homozygous, the B, homozygous, and the C is the only one that is heterozygous. So you will not have a lot of options because of that. So 2 homozygous and 1 heterozygous, it will be 1 multiplied by 1 multiplied by 2. So you will only have 2 options. And you can do it also like this. So based on this, you have 1 option for the homozygous, 1 option for the B, and 2 options for the C. In both ways, this work, and it is not complicated. Use the one that works better for you. Okay, now this question. In this question, if you see, I highlight again 3 sections, so please read it, and I will try to answer the question. Okay, so how we answer this question? Generally, they tell you, for example, 10 homozygous genes, so they tell you that you have 1 gene that is homozygous, 2 genes that are homozygous, 3 genes, and 10 like that, yeah? And then they tell you that you have 5 heterozygous, so I don't know, the next letters, L, and you have M that is heterozygous, then N heterozygous, O heterozygous, and P heterozygous. And if you remember, the homozygous is multiplying by 1. Let me put it in green. It's always like multiply by 1. Well, the heterozygous is like multiplying by 2. So here it will be 1 multiplied by 2 out of 2 raised to the power of 5. So this will be 32. Yeah. Here they don't give you the genes. They just tell you that one is homozygous, that 10 are homozygous and 5 of them are heterozygous. But remember, when you have a homozygous one, the homozygous is like multiplied by 1, and the heterozygous is like multiplied by 2. And if you multiply 2 5 times, is 32, or is similar to raised to the power of 5. And now I'm going to show you a formula that some people ask me if I can show them formula that they can apply, so it's very fast and you don't have to think so much. This is again a way to explain this exercise. So when you have a heterozygous gene, you have, if you see here, you see you have 2 alleles, so you have 2 type of gametes, and you will get to, it will be 2 raised to the power of 1. This will be the formula. Why? Because when you have the number of alleles for a heterozygous, it will be 2, and in red is the number of genes. Now, when you apply it to a heterozygous, when you have 2 genes, you have 4 options, as we already talked, or you can just apply this formula. You have 4 gametes because you raise this to the number. You have 2 alleles and you have 2 genes, so it's 2 raised to the power of 2. When you have 2 genes, it will be like this one, and this one, as we said, is multiplying. It's 3 heterozygous, so it will be 2 multiplied by 2 multiplied by 2, so it's 8. Or you can just write that every time that you have, this is the number of allele, and the 3 is the number of genes. So how many genes? How many genes? You have 1, 2, 3, A, B, and C. And how many alleles? 2, because in these exercises you have only the option of capital and lowercase, because it's the normal genetics. And this is the formula. So every time that you have a heterozygous, you have n is the number of allele, and 2 is the number of alleles, and here the n, it will be the gene. So if you have 5, it will be 2 raised to the power of 5, or 32, as we solved it in this exercise. And just to make things, in case that you have a doubt, when you have a homozygous, as I said, you have no option. So it's like, instead of having this, that you have a heterozygous, that you have 2 that are different, you have something that is the same. You have 2 that are the same. So there is no variation. So you have only 1 type of gametes. So again, the green is for the type of gametes, for the versions of the allele, and the red is for the number of genes. So you are only going to have 1 type of gametes. When you have 2 homozygous for 2 genes, again, it's like this exercise. So you just multiply 1 by 1 by 1. All of them will look the same. So it's 1 raised to the power of 2. And when you have 3 genes, it's like having all these 3 genes, 1, 2, and 3. 1, 2, 3 genes. But all of the alleles all the gametes will look the same. Although we, again, raise it to, you have 3 genes, but you only have 1 allele. So 1 raised to the power of 10 will still be 10. And remember, this is you use the multiplication rule. So the answer for this one, very easy. This multiplied by 2 raised to the power of 5, because we just saw that. So this will be equal to 32. Okay, so again, this is another way to solve this exercise. It's again the same logic. And remember, if you have only two alleles, you will have 2 raised to, for example, if 2n. If you have 3 alleles, you just have to have 3 here, and this will be the n will be the number of genes. So not complicated. And if you have any doubt, just let me know. Send me an email. And here, let me delete this. Here with this one, I just wanted to show you that no matter how many times you multiply this homozygous, you will still get 1. Okay, so this is the information for the formula for the homozygous in case that you wanted to see it. Okay, this is super easy again. I have shown you 3 ways to solve this exercise. Let's try to do it. So here you have to find gametes, and you have how many homozygous? You have 3, and you have 2 genes that are heterozygous. So here you find the 3 homozygous. You have to multiply by 1, or you can just and when it's heterozygous, you can multiply by 2. I also show you that you can do this also in a similar way with those trees, or also with this formula that you can also just, when you have homozygous, you have only 1 allele and you have 3 genes, and here when you have heterozygous, 2 alleles and you have 2 genes, so it will be like this. So it's the same thing. So now, as is multiplication rule, you multiply, and this is in all the different ways that you do it, you will get the answer that it will be 4. Here, as they don't ask you to tell me the gametes, you don't have to say if it's A, B, C, D, E, or A, C, A, B lowercase, C, D, E. You can just do it with like this. If I ask you to have the gametes, you can and give me the examples. You have this is a good way to do it with the tree that I already showed you.